Connecting graphs to equations, Part 2. In this video, you'll learn how to find the slope and vertical intercept of a line with the equation ax plus by equals c. You'll also learn how to take an equation in standard form and rearrange it into the equivalent form of y equals mx plus b. Let's start by looking at slope-intercept form. The slope-intercept form of a line is y equals mx plus b, where x and y represent any point on the line of the graph. M represents the slope of the equation, and in real-world situations, the slope represents the change or how the situation is growing or shrinking. And B represents the y-intercept, so in real-world situations, this represents the starting or initial point, since this is when x would be 0. To convert standard form to slope-intercept form, we just need to solve for y. So let's look at an example. Let's analyze the equation of May's bus pass situation. She starts with a balance of $40 and spends $2.50 per school day. We'll put May's situation into slope-intercept form. We know that m is our slope and represents how the situation increases or decreases. We see that she spends $2.50 per school day, so her situation decreases by $2.50 a day. So we can replace m with negative 2.50 since we're subtracting. We know that b represents the y-intercept or our initial value. Since May starts with a balance of $40, we can replace b with 40, and now we have an equation to represent her bus pass situation. Here's another example. The graph below represents a is equal to negative 20t plus 450, which describes the relationship between gallons of water in a tank and the time in minutes. So we can see that the x-axis represents the time, and the y-axis represents the gallons of water. Let's bring our equation down so we can analyze what each part means. In slope-intercept form, we're used to seeing the variables y and x. We can use other variables and still assume that it means slope-intercept form. So a will represent y and t will represent x in this case. Now, where on the graph can we see the 450 from the equation? We can see 450 on the y-axis. So 450 is the y-intercept, and this makes sense because we know that the b value always tells us the y-intercept. Where on the graph can you see the negative 20 from the equation? Since our equation is in slope-intercept form, negative 20 should represent the slope. So we'll look at our graph a little closer just to make sure our slope is negative 20. So we'll zoom into our graph, and we'll call this point A. And this will be point B. We can have used any points on the line, but these both cross at nice intersections, so we'll use this for our example. We know that slope is how y changes over how x changes. So let's look to see how our points change from going from point B to point A. We'll start with the change in y. So this is how much we have to go up to get to point A. Point B started at 50 and went up to where A was at 250. So our y value increased by 200. So we'll put this on top of our slope formula. Now let's look to see how x changed. It started on the x-axis at 20 and went backwards to 10. So we can replace our x change with negative 10 since it went backwards 10 units. Simplifying 200 divided by negative 10 will give us negative 20. So now we can confirm that negative 20 is the slope. What do the numbers 450 and negative 20 mean in this situation? We know that they're the y-intercept and the slope. So 450 represents the gallons that started in a tank, and negative 20 shows the rate of change that the water decreased each minute. Here's another example. The graph below represents 4x plus 2y equals 10. It describes the relationship between pounds of almonds and figs and the dollar amount that Claire spent on them. Suppose a classmate says, "I'm not sure that the equation is correct because I don't see the 4, 2, or 10 on the graph." How could you show your classmate that the graph is correct? Well, the original equation is given in standard form, and standard form doesn't show the numbers as clearly on the graph. So let's put it in slope-intercept form and see if those numbers appear. So we'll take the equation they gave us and we'll put it in slope-intercept form by solving for y. We'll start by moving the x term, so we'll subtract 4x from both sides. This gives us 2y is equal to 10 minus 4x. Now we'll divide by the coefficient of 2 on both sides. This gives us y is equal to 5 minus 2x. Slope-intercept form always has the x term first, so we'll rearrange the equation. We'll get y is equal to negative 2x plus 5, and now we can see the slope and the y-intercept a lot more clearer. So if we take the slope-intercept form of our equation, we see that 5 is our y-intercept, and it matches the graph because it crosses the y-axis at 5. Our slope is negative 2. And when we look at our graph, we can see that we have to go down 2 units and over 1 to get to the next point, so our change is negative 2. We'll find the slope and y-intercept for each equation below. All of the equations are currently in standard form, so we just need to solve each equation for y to put them in slope-intercept form, and then we can identify the slope and y-intercept really easy. We'll start with our first equation by adding 4x to both sides. This gives us 3y is equal to 3 plus 4x. Now we'll divide both sides by the coefficient of 3, giving us y is equal to 1 plus 4/3 x. We'll switch the order of our numbers so that it's in slope-intercept form. Now we can easily see that our slope is 4/3 and our y-intercept is 1. Now let's look at 12x minus 4y equals 8. We'll start by subtracting 12x on both sides. This gives us negative 4y is equal to negative 12x plus 8. Now we'll divide both sides by the coefficient of negative 4. This gives us y is equal to 3x minus 2. So we can see that our slope is 3 and our y-intercept is negative 2. Now let's look at 8x plus 2y equals 16. We'll start by subtracting 8x on both sides. This gives us 2y is equal to negative 8x plus 16. Now we'll divide both sides by 2, which gives us y is equal to negative 4x plus 8. So our slope is negative 4 and our y-intercept is positive 8. Now let's look at our last equation. We'll start by adding x to both sides, and we'll get 1/3 y is equal to x plus 1/3. Now we need to get rid of the coefficient with y to isolate it. When we have a fraction, we're going to multiply by its reciprocal to remove it. Since the reciprocal of 1/3 is 3 over 1, or just 3, we're going to multiply both sides of the equation by 3. This will give us y is equal to 3x plus 1. So our slope is 3 and our y-intercept is 1. Let's recap what we've learned. Linear equations can be written in different forms. Each form has its advantages and disadvantages. In a real-world situation, the slope tells us the rate of increase or decrease, and the y-intercept tells us the initial starting point.